Hello and welcome to another mathematical studies video. I'm going to go through quadratic functions. We already saw a few things about them. Let's revise them. We saw that this is the form a quadratic function has. So I have the x squared and then the x and the no x, and I have the coefficients of each one of the parameters of the polynomial. So I can solve the quadratic formula using this equation available in your formula booklet. So here are some of the parabolas, and the consequence of this equation is that the square root sometimes will have a negative value inside. Hence, the parabola or the quadratic function will have no roots, or it might have one root, like in the case here of the green one, or you can have two roots, 1 and 2, in the case of the blue one. So here are some common features of the parabola. This is things that you need to know. So all parabolas will have, look at this one carefully, they'll have an axis of symmetry. They'll have an axis in which we can actually fold the parabola and we could see it on the other side. We can calculate the axis of symmetry by taking again my a, b, and c parameters and just doing minus b divided by 2a. So for example, if I have this parabola here, I can find the axis of symmetry. It'll be minus 2 divided by 2 times 1, all of it negative, and hence I get 1. So x equals 1 is the axis of symmetry. Here's x equals 1, the green line here. And of course, in that axis of symmetry, there's also the vertex of the parabola. So again, the x coordinate, I just obtain it the same way as I obtained the one of the axis of symmetry. And I just have to substitute with x equals 1 in the function to obtain the y coordinate, which in this case is minus 2, so the vertex is at 1, minus 2. So the parabola can be moved around. I know what my parabola y equals x squared looks like. So if I add a number to it, it's going to move upwards. If I subtract a number to it, it's going to move downwards. Look at the green one here, x squared plus 2. Realize how it's moved 2 units up. Horizontal translations work in a similar way, but I'm not adding to the whole function. I'm adding a number or subtracting a number right next to the x. So here are my horizontally translated parabolas, and here are the way in which I have translated them. So realize how, again, the green one here has moved 2 units to the left. Excuse me, not to the right, but to the left. So important to realize how I added a number and it moved to the left. So horizontal translations work the other way around. Finally, the stretching. How does the stretching work? Well, I can stretch a parabola by multiplying by the function by a number. So realize this one's here. The red one here is f of x equals x squared. So 2x squared, I've kind of stretched it vertically. I've pulled upwards the parabola, and now it's more stretched, more vertical. This one here, f of x equals 1 half over x squared, times x squared. This one here has been compressed vertically. When multiplied by a bigger number, the function stretches vertically. When multiplied by a number between 0 and 1, the function is compressed vertically. Now, note how the function faces the other way when multiplied by minus 1. This is what happens when it multiplied by minus 1. Now, all of these things are actually not that relevant because you have a calculator with you. You have your GDC, and you can just plug the formula in and take a look at what it looks like. Here's how that's. Again, simply you press the Y key to access the function menu. You press X and X squared, and then you'll have the actual function show up. Now you can press enter and grab. Of course, if you have a different function at this point, all you have to do is include that function here. You have the parabola drawn. Now, how do I find any information about it, such as the vertex, axis of symmetry, roots, intercepts, etc.? I just have to press second and the key that's called trace. I'm actually going for the calc menu. And this is how it opens up. So on here, if I choose 0, I will find the roots. If I choose a minimum, it will let me find the vertex. Keep in mind that this one here is x squared. So at this point here, the vertex is going to be a minimum. If it was minus x squared, I would have to click on maximum. I can also find the intersect between with another function and particular values of it, and even the derivative, which we will look at later. Thank you very much for your time. I'll see you next time.